tell us about why you should enjoy JavaScript. So that's what.
I might actually say that you should not enjoy JavaScript so much, because the talk is going to focus on malicious ones. And the statistics right now say that more than 75% of any problem that you have in your computer comes from your web browser. And out of that 75%, more than 80% come through the form of malicious JavaScript. So today I'm going to tell you about what I have done in terms of research and also what others have done in terms of research to protect you guys from kind of getting infected with the viruses that come in the form of the JavaScript. This is a joint work with my PhD students, Peter Lukarsh and Jung. And some of it was published in International Motions and this occurred conference. I already told you some of this already. You can see that the number I told you is slightly higher than the number on the slide. The new numbers are just published, so it now has gone up more than 60. If you think about the time that you spend on your computer, I think it makes total sense. Most of you probably have a web browser open all the time while you're at your computer. I do this survey every time I teach security class, and I ask students how much portion of your time that you are online, how much of that portion of the time you have an online browser. It's usually at least 90%, if not 100. You don't ever close your web browser until you have to. When you reboot your computer, it's probably when you reboot your web browser. So web browser, even though this is supposed to only give you the access to the websites and pages and things, now has become pretty much its own kind of an operating system. So an example that I can give you is a Google Doc. You can do documents that originally people thought it's the holy area of Microsoft Office. Everybody had to purchase some kind of office software, Office or some other ways. But we thought that this is something that's so slow and so complicated, you have to do it in your computer. And now you can do those functions in your browser. So what's the difference? Web browser functions and what you can do outside the web browser. The distinctions are getting blurred every single day, and that's why we're seeing more and more attacks through your web browser, because your operating system has seen viruses for a decade at least or two, and your web browser hasn't seen that as much. XSS is an acronym that stands for cross-site scripting, and this is one of the most prevalent bugs on the web. So the drive-by download is something, it's kind of an attack. You don't have to do anything. You simply visit the website, and the website installs a tiny bit of program in your computer, which turns out to be malicious. So it's called drive-by download because you only need to visit. You don't have to do any action. Malicious advertisements, I'm sure you have seen those and got annoyed by them, but it's even worse than just simply annoying because it also installs bad software in your computer. You could take over somebody else's browser using a JavaScript combined with somebody's web browser that has vulnerabilities. There are proven things. How many of you know Fireship? Okay, Fireship is something that you can install in Firefox and go to a public network where if you're not careful enough, then other people can copy your Facebook logins and other login credentials and pretend to be you. I believe Facebook actually has fixed that bug since the release of the software, but you can still go to YouTube and see the demo. If I were using the same wireless router as somebody else, I could copy their login information. It's not the same as password, but it's something that you can use to prove you are you temporarily. If you know cookies, it could copy the cookies in. So taking over a lot of different things on the web could be done through this cross-site scripting or cross-site request forgeries. So if you ask, say, programming language person, programming language researcher, or really hardcore theoretical security person, it's like, okay, so JavaScript is giving us all this headache. What's wrong with it? Most of you will tell you, say, JavaScript is not a good language for security, period. JavaScript has very, very, how do I say, open structure. So JavaScript can call any other things in your computer. It can call your Adobe PDF reader. It can call Visual Basic scripts. It can call Excel. It can call Word. It can call anything in your computer. So inherently, JavaScript is not a safe language to use. However, almost every single website that you go to has some kind of JavaScript. To show you how this is so pervasive and not really noticed, I'm giving you your own department website page. You probably have noticed that there's this yellow bar that most of you do not have. If you're interested in security or JavaScript, I highly recommend this add-on. It's called NoScript. It blocks any scripts from running. And you can say, okay, I'm going to allow sonoma.edu because I trust my university should be doing the right thing. But have you thought about this company called GoogleAnalytics.com? How many of you know what Google Analytics is? Okay. So Google Analytics is the tool. It's almost free, I think. Free tool that Google has published so websites can track where users are coming from. So if you go to that website with the ID number that's assigned to this particular web page, it tells which countries the visitors are coming from, at what time, when was this website most popular, all these kind of statistics, which is really useful if you're running this website. But did you know this is in this website in the form of JavaScript? If you go to, for example, say, this is supposed to be a free website for great references. I think it's a combination of 7 different dictionary sites. And you can see that it actually is trying to do something with the Facebook. This is actually part of the Facebook. So these together, you probably did not make the link. Why is Facebook doing something here? Right? This is a dictionary website. What's going on here? You can see that they want you to like this website, this word, this particular day of the word, every word of the day. These functions are provided by Facebook in the form of JavaScript. So wherever you go, I can pretty much guarantee you over 95% of the websites that you visit and has a like button is recording your visit in Facebook. No matter what you do in that website, doesn't matter. Facebook knows that you are there, especially if you have Facebook login and visit that site at the same time. Facebook can tell that, oh, this person likes this page. This person is visiting this page, even though that person did not like it. So JavaScript is everywhere. And most of the times I would like to say they have good intentions. But some of them are not. Some of them come with the malicious intentions of giving you viruses, giving you malicious software, giving you this monitoring software that will quietly collect your passwords and usernames and send it to somebody else and sell it. Quietly collect your credit card numbers as you tap it into Amazon.com and just steal it and pass it to somebody else. So what I want to do is to do something non-invasive. And what do I mean by non-invasive or invasive? This is actually a very well-defined term in industrial engineering or many different kind of engineering. This means that if this test renders the goods unusable, then this test is invasive. A classic example is to cut, like fruit is just one example, but opening the fruit package, because once you open the package, you have to eat in certain number of days, right? So opening the package of some food item to see if the food is still good is considered invasive. If you have to cut like a very nicely sewn clothing and see what's going on inside of the clothing, you cannot use that clothing anymore. So that's considered as invasive. If you do X-ray on camera films, you probably don't even have seen the camera films for a while by now. But if you pass your bag with the camera films in it through the X-ray at the airport, your films are not usable anymore. Those are the detections that are totally invasive. So in JavaScript detection, what I'm claiming as invasive is something that will make you not do what you wanted to do. So I want to go to sonoma.edu, I want to find information there, and I couldn't do it. That is invasive. Let's say I could do it, but I had to sit there and wait for a minute. Okay, come on. That's not going to be good. The statistics and the research say that if you have to wait more than 0.2 seconds, you're starting to get annoyed. If you think that it sounds a little impatient, when was the last time you waited for a split second for something to show up in your web browser? There's usually something that starts to show right away. You may not have the full picture, you may not have the full movie. Something starts to show almost right away, and there's a reason why we do it that way. So, if you have to experience significant inconvenience, then I'm going to call it invasive. So what I'd like to do is to make this mechanism, the detection mechanism, non-invasive. So you can still enjoy most of the functionalities of the web. You can still do what you want to do without waiting too much, and still provide you some kind of protection against the malicious ones. What has been done before? You probably have seen firewalls and virus scanners already. Most of your operating systems come some part of it already. So blacklist-based approaches have a list of known bad ones. So if I know that certain JavaScript is bad, then either you can report that JavaScript or kind of the essence, the summary of it, or profile of it, and make the list of it. And you can compare that, compare wherever you want to visit against this list, and if it is in the list, then you can safely say that, okay, you should not go there. This is a bad idea. Similar idea has been used in, say, Google search. You might have seen that this website may harm your computer. This actually comes from the blacklist as well. And you might have seen Firefox and Safari, and I think Internet Explorer does that as well. If you're trying to visit a phishing website, then it'll say you shouldn't go there. This website is known to be bad. You should not be going there. So this is something that we can do for sure. And most virus scanners have some kind of this blacklist. They have different sets of profiles of the software, but most virus scanners and the firewalls have kind of that system. So this is not very invasive. Checking against the list doesn't take very long, and you can still do it as long as it's not in the list of known malicious JavaScripts, and at the same time, if you were in the malicious JavaScript list, you should not be doing that, right? The sandbox-based approach is basically saying that we're going to have a virtual machine separately away from your computer, or even inside your computer. We'll have this isolated environment to run this script and see what happens. And if it does anything malicious, you can do this particular website. You can visit, run this particular website, and if there's nothing wrong with it, then sure, we'll let you run this script. You might have noticed already, but running this isolated environment is very, very heavy operation. If you have run virtual, whatever, say VMware, virtual desktop, or virtual anything in your computer, you might have noticed that those things are usually slower than you're just using your computer. So this is invasive, and I can tell you how bad it can be. It can take as long as full 4 seconds to load a page, and most people find it unacceptable. So that's why I'm calling it invasive. If you are familiar with the HoneyNet, Honeypot, any of these Honey series, then this is the usual approach, because we have time to investigate. It's not interactive with the user. Limited capability approaches is something that Google is pushing for right now for JavaScript, just because JavaScript has so many holes. So Google has its own version of JavaScript and say, we should just stick to this subset of the JavaScript. It'll be great if that happens, but not everybody is going by the Google's rules. And at this point, it's not going to be any day, even this year, that it's going to be pervasive as much as currently this full JavaScript is. Not only it's not adopted fully, but also it's going to give you limited functionalities. So if your web browser decides to go with Google's subset, then there might be websites that you can't visit or function or interact with. So that I call invasive. Well, if they were perfect, then I wouldn't be doing research in this area. The black box ones have something called zero-day vulnerability. If you have read about the network worms in 2003, you might have heard of Sapphire worm that has practically, how do I say, killed the world internet in 2 hours. It's very fast. It goes out very fast. It infects many computers in exponential speed. So zero-day vulnerability means that the day that particular problem first came out, nobody knows what it is. Nobody knows how to detect it. Nobody knows how to counterattack it. So zero-day vulnerability is usually the worst day of the attack and the worst day of the damage. So if you are using blacklist, you can't really respond to new ones correctly. And right now, the number says that malicious websites, I'm not talking about a script, but a website, if that website was designed to be malicious by bad people, they live long, about a week. You might think that a week is not too long, but then I can tell you, after it gets blacklisted, they run away very quickly. There's no point of hanging around because they're already blacklisted, they're not gonna make more money, and they might even get traced back if they linger around. So as soon as they get blacklisted, they just fold their operation and go to a different website. So current statistics say that they are only around for about 24 to 48 hours after they get blacklisted. So if you subtract that from the week's lifetime, you have 5 to 6 days of being protected by the blacklist-based approaches. So you might have heard how the virus scanners can catch something after, days after, weeks after you have downloaded something that has a virus. That's how long it takes to update the blacklist. So this has the window of the vulnerability. As I said, sandbox-based approaches are slow. It's usually not acceptable in terms of web surfing. And also, if your sandboxing is not perfect, then it's not going to give you the isolation or the protection from running it in the environment. If you have run any of the virtualization software, you might have linked a folder from your virtualized operating system into the real operating system. That is a leak. So if anything happens in your virtual box, that can go into your real operating system and write it down into the disk. Immediate capability, again, has the compatibility issues. If we all move to a subset at the same time, great. But in the internet, nothing happens in that quickly. So here's what I'm proposing, not just I'm proposing, the whole community of this JavaScript research, malicious JavaScript detection research is going, is that we're going to have layers of detection. The first layer has to be non-invasive, so you can work with your web browser for most of the time without having too much difficulty. And then we can spend more time and use the invasive methods in the second line of detection. So it's kind of a triage system. We're going to get a bunch. Every website has many JavaScripts. Even the simple-looking department website had at least 2 different scripts running, right? So in our data set, the average was 7. There are 7 scripts per page. So if you spend 1 second per script, you are already counting 7 seconds away, which is too slow. So what we'd like to do is to do the triage really quickly. If we know for sure this one is going to be good, we want to let you run with that script so you can have some website contact, you can interact with them. And if we have any doubtful ones, we send it to the second layer, and the second layer is going to use these invasive methods to find exact answer. So the first one may give a doubtful one that is not malicious to the second line, but that's okay as long as it can do a good chunk of the good ones. So it's more important in the first layer that it's fast and it can identify good ones. So if I get 7 good scripts, and if I can start with 5 right away, and then 2 are going to come a little later, this is much better than every 7 has to go through, every 1 out of 7 has to go through a slower process, right? So you can think of the first layer as kind of a triage system. So here's the whole kind of framework picture. So we'll start with the web crawler. And web crawler simply collects the samples of good and bad ones. And we pass it to, so we collect these candidate files, we pass it to the classifier. We'll talk about that in a minute. And this classifier is the first layer of defense. This is very fast. I have run it with people. I have measured in the time, the computer in milliseconds. This one hardly takes any more time than the network delay that you already have. Getting the content from the website consumes some time, right? So the delay from the classifier is minimal. So as long as you can get a big chunk out that way to the benign JavaScript portion, we let the user interact with those scripts in the website, and the rest of it. Right now we do manual inspection. We're getting some more interesting and intelligent backend. And if they are confirmed to be malicious, we feed it back to the crawler to find more like them. And also we feed it back to the classifier for better training. This is an example of a good JavaScript. Looks simple, right? Looks all good. And this one is very readable, makes total sense to people. This is an example of a malicious one. It's kind of obvious, right? Once you see that, it's like, oh, I mean, that's like a nonsense. You know, that should be malicious. There's one good news and one bad news. So if you're kind of a security researcher, and security researcher tends to be more pessimistic, you probably want the bad news first. The bad news is Google Docs scripts look like this. The reason is they want to compress those JavaScript functions as much as possible because there are so many operations in this Google Doc operations, and also you can imagine how users are interacting over, say, mobile phones and very limited bandwidth. So they compress their script to the point of this. So if you're just thinking that, oh, I'm going to just read a script, and if it has any garbled-looking string, I'm going to call it malicious. Tough. Not quite that easy. The good news is, however, if you look at all this kind of obfuscated, that's an official term that is very garbled, obfuscated scripts, 99% of them are malicious. So if you say, okay, because this is garbled, I'm going to put it in a temporarily malicious pile, and then I'm going to look into other different things, then you probably can do your triage really quickly. So the clue that we have gotten is that obfuscation, over 90% of the malicious ones in our data set had obfuscation. And if they were obfuscated, 99% of them were malicious. So we are using that as part of the clues that we use for detection. You might think that, well, if it's compressed or garbled, any of that, why don't we reverse engineer it? You know, it's such a small program. You should be able to reverse engineer and see what happens. Complete the obfuscation when somebody created a code intentionally is extremely difficult to the point that it's almost impossible. It's proven in 1993 that if you change the control flow, like the if statements, switch statements, for loops are actually not that difficult. If you change the switch statements with the conditions, then it is extremely difficult to reverse that back to non-obfuscated version. So it takes a lot of time, so it actually gives you invasive delay when it comes to web surfing. And also, it's this point, if you want to de-obfuscate something that is compressed, it's not going to give you what original version had. It's going to give you a version that looks reasonable to you, and it's going to do the same thing as the obfuscated version, but it's not going to bring it really back to the original one that it started with. So de-obfuscation not only takes a long time, it's not the most efficient way to find, okay, what is this script really doing? And that's why a lot of people resorted to running it in the isolated environment and see what happens. we do partial deobfuscation. We do a little bit of the deobfuscation to extract more URLs. Most of the JavaScripts are linked to other malicious JavaScripts, so we get these links out of it and use it. And also, if you are using deobfuscation, okay, so you have this something deobfuscated code. How do you know whether this is malicious or not? You still either need to run it in sandbox or match it against the blacklist. One of the things that we are focusing on is that you only need to know that this is obfuscated. We don't actually need to deobfuscate it to say this is likely to be malicious. So we have lots of clues, and in the official term of text classification, we call them features. Features that help us to know that there is some obfuscation going. So just to give you a little bit of idea, when humans see this, we know this is garbled. We know this is obfuscated, no questions. How would you make your computer know that this is obfuscated? Can you write a program that will give you the absolute answer? Yes, this is obfuscated. How do you automate it? It is not a trivial question. At this point, if we actually could do that, then we'll have much, much better progress in software engineering, because that will give us a tool to detect whether some code is better written than others. So knowing that this is obfuscated by itself is a difficult question to answer. By the way, if you have any questions, feel free to interrupt me at any time. I welcome questions. I'm assuming that most of you did not take a data mining class or AI class or machine learning class quite yet. So if you already know this, well, maybe it's a good refresher. If you do not know, this is the real basic of the classification. Classifiers learn from training set to do something. And this is really like training a monkey. If you have seen any of these psychological experiments that teach a monkey to find a way to unlock his cage and get the banana outside of his cage, this is pretty much the same thing. You give the answer, you give the data set that has a definite answer. We call this ground truth. So you give the classifier a bunch of malicious JavaScripts and a bunch of benign JavaScripts and say, this is good, this is bad, this is good, this is bad. So classifier learns by looking at all these samples and kind of develop its own rule. It can be probabilistic analysis. Oh, if this particular thing happens in the script, this is likely to be benign or malicious. It can make a decision tree, like a binary decision tree, and say, okay, does this have this particular function? Yes, no, and make this kind of decision tree. You can come up with the rules, and also there's other hyperplane method. I'll show you the SVA picture later. Example classifier that I'm going to walk you through is called naive Bayes. And this is not as much as used right now in spam filtering, but the first breakthrough that we have made, we as in the computer science altogether, came from using Bayesian classifier. So before that, the detection rate of spam was like 30 to 40%. And after we adopted Bayes classifier and other classification, it shot up to 60 to 70%. So if you have less spam in your inbox, it started with the Bayes classifier. This is a math theorem, and you don't have to remember these equations to know this stuff. I'm just giving you this version just so that you can feel like, oh yeah, I know that, and you feel good about it. But the real example is right here. Let's say I want to know what is the chances, what is the probability of this particular email being spam if this particular word stock is in the email. There are a few words that you can probably quickly think of. If I see this word in my email, I know this is spam. I know if that particular email comes with, you have a message, and since it says it's from Facebook, and the sender name is not one of my friends, I know this is spam, right? You probably have some of these tricks that you can come up with already. And this is a way to teach the computer how to do it. I am interested in this one. Given the word stuck in my email, I want to know the probability of this email being a spam email. And the theory says if I can calculate these three different probabilities, then I can compute the left hand. And the right hand, it's actually something that you can calculate if you have this good sample, or even the whole internet spam altogether, then you can calculate these probabilities very correctly. This one says what is the probability of any given email being a spam. Right now, the statistics say that 94% of any email that goes through the internet is a spam. Isn't that surprising to you? I think it's really surprising because I don't have 94 spam emails per 6 good emails that I have in my mailbox, even including the trash box, right? So this surprises me. And this also goes to how great in spam research has advanced. But anyhow, so this probability right now is something like 0.94. This probability is given any email. What is the chance of this email having the word stop in it? Well, this you can calculate if you collect all the emails in the world and actually do the counting. And this one says, given that this is a spam email, what is the probability of stop appearing in the email? This you can also calculate if you had all the spams in the world in your computer and count it, right? We don't have access to everything in the world, but if I do good sampling of emails, I can get a good estimate of all these probabilities. And this great mathematician, old days, someone called Bayes, says if I can do this, this is calculable. So once you have this probability, what you can do is that whenever you get an email, you look into it and see if there's a word stop, and this probability is higher than, say, even 70% or 80%. You can simply put this in the spam folder. Make sense? Kind of. You can use more words, not just stop. There are many other different words like mortgage, refinancing, or free medicine, or cheap medicine, like all these keywords that you probably have seen in your spam mails that you can build into the system. So usually as you add more words, you get better accuracy. But if you have n different words, then you might have this challenge of you have to calculate 2 to the n probabilities. So, okay, I have stock but not mortgage. I have stock and mortgage. I don't have stock but mortgage. Like you have these combinations. So if you have n words, technically you have to calculate 2 to the n different probabilities. So you can't, in a nutshell. I mean, if you get a dictionary and do all different probabilities, it's going to consume too long. So what we do is that we assume that there are independence. There's independence between the words that might appear in spam, which is not true, which is so not true. Refinancing and mortgage are very much related. So this is why it's called naive. But in return, I only have order of n, like just n probabilities to compute, to work with n words. So I can simply compute this, assuming that the stock and jackpot are kind of independent words. So this is kind of the end of the Bayes classifier, but as long as you could understand the probability part, then you're very good to go. What the classifier is going to do, given a set of words, it's going to give different weights to each probability. Does stock make your email more likely to be spam, or does refinancing? So there's different weights per word, and classification will do that for you. This is just a slide to show you that there is something called support vector machine. Currently, this is the best classifier for the text classification. If you are interested about this, I highly encourage you to come and talk to me after the talk. This particular input space where we have this kind of curly curve to divide between red and blue, you can add another dimension and make it three-dimensional data space and find a plane instead of a line. So this one gives a very, very good result if your data points are mixed. So this one probably is something that you will do if you are an expert in the data mining. this is probably the last slide that I'm going to give kind of a lecture at the moment. I just want you to understand the concept of true positive and false positive. Positive here is, this is actually the same metrics that people use in medicine. Let's say I have this screening method. Maybe I have this cancer screening method. I'll do a CT scan of your brain, and this one tells me whether you have a cancer or not in your brain with 90% accuracy. Okay? You might have heard that no screening is perfect. So there are still chances that you have something tiny bit, and it doesn't show up in a CT scan, right? So how do you know something is good enough? True positive is that if it is positive, if it comes out as that somebody has a cancer, then this test is going to tell you that yes, this person has a cancer. False positive is when the test says that this person does not have cancer for real, but the test says that this person does. And the false negative is the dangerous one, when the person has a cancer and the test says no. True negative is a good one because the person does not have a cancer and test agrees. So these are good things. If that's true positive, true negative, either way, it's a good thing for the test. It means that test is more effective. These, however, are the bad ones. If it tells me that I have a cancer and I don't, I'm going to totally freak out, which is not a good thing. If I have a cancer and the test tells me that I do not, I'll totally freak out and still not be happy. So what you can think of in terms of JavaScript is that this one is malicious, and my classifier tells me it's malicious. This one, the classifier says it's benign, it is actually benign. This one is actually better than this one, because if it's false positive, and it is okay, it is a benign script, and my classifier tells me, no, I don't think so, then what I can do as a first layer, I can pass it to the second layer, put it in a sandbox, and let it run. False negative is a worse one, because this one, I'm going to let you, user, interact with this particular script, even though this one is malicious. So this is a bad one. I'm going to show you this real quickly before I go back to the theory. So what I'm trying to do in the reality is that I'm not perfect. My research is not perfect. My software is not perfect. So what I'd like to do is that given the imperfection, I'd like to minimize what I'm going to say good when it's not good, right? So these numbers say I can collect 99% of the good ones and call them good, which is good, right? Because 99.6 or 7% of the time, if that script is a good one, then you will be able to interact with those scripts and the website. So it's non-invasive. It's not going to hurt your interaction with the website. On the other hand, this, I'm not too proud of quite yet. We're about in average 90%. This one is saying that if we have a malicious one, then if the classifier says malicious, then how much can you trust that decision? So if I have this true positive, the malicious one being classified as a malicious, and the false positive that is not actually malicious, but my classifier says malicious, divide the true positive number with the sum. So this number being lower than, say, 99%, for example. So right now, we average about 90%, which means if I call something malicious, my classifier calls something malicious, 1 out of 10 is actually not malicious. We are being oversensitive. I'm worrying too much. But I'd rather have that problem than having the false or negative and let you interact with the bad one. Because it only takes one virus to crash your problem, crash your hard drive, and crash your whatever sensitive information that you have in your data is to be stolen away, right? So I'd rather have false positive than false negative. So right now, this number is about, in average, 90%, which again means that if I have 10 of these, then I only get 9 that is truly malicious. It's not that great. We're improving that number, but still we haven't made a big progress on it. On the other hand, what I've been trying very hard is to keep this number very, very high. So if I have 99%, that means if I have 100 of the negative ones, then 99 of them were truly negative, in other words, truly benign. So 1 out of the 100 scripts that my classifier passes as okay was the one that it should not have passed. And if you remember the numbers, 99.7 actually says it's less than 1. Most of the times, you'll see just the good ones interact with you. I think I'm getting out of time, so let's skip up these slides. We don't have the greatest number in precision, have a good number in the negative prediction. I wanted to show you that we have tested with different classifiers. They run pretty much the same. These were run with the data set we knew which one was good, which one was bad. But it's not as interesting if I'm only working with the past data. I want my classifier to work currently. So what I have done is to find 2 weeks data from this maliciousdomain.com. This one has the list of malicious domains on the web, and we found about 24,000 unique scripts by running the hash, and we found 22 malicious scripts found by our classifier. And I ran 2 leading virus scanners, or actually 1 leading virus scanner and also 1 leading website that analyzes the malicious JavaScript, and only 2 out of this 24K were found to be malicious. So we have pretty good number compared to them. You can see that different classifiers have found different numbers, and again, you can see that our precision, we have about 90, I think RP and SVM, if you do it multiple times, we average about 90%. So, what am I doing now? I'm using some more advanced classifications to improve the classification. And also I'm adding this with the user interface, like what you see in the Internet Explorer and Firefox. It says, this is bad website, you shouldn't go there. And they usually have some link that you can visit to see why this is listed as a bad website. We have done something more conversational to tell you exactly why we think that this is bad. So it's more educational. We have done it with phishing, it was well received. We're building it with JavaScript as well. The rest of it is probably more details in the classification, except for this one. We're testing the resilience, meaning that how good our classifier can be over time. We have done training once and run it. That was good. We're keeping this periodically to see how our classification evolves over time. That's for now. And I'd like to thank my colleagues and my students that have helped me very much. That will be it.
One or two questions?
Yes.
Do you guys have a PhD program that you're like, are you running?
No, we only have a master's program. I have PhD students in my previous institutions and I still work remotely.
Oh, okay.
But we have a master's program.
Okay.
Yes.
Doesn't Google Chrome sandbox all their...
That's an excellent question. Google Chrome sandboxes their tabs, and that was their real punchline for their improved security in the web browser. The problem there is that Google Chrome has to rely on third-party plugin for, say, like Adobe Reader and, say, Active whatever thing, or codec player. If you want to place a movie inside of your web browser, then you have to use some other video program, right? Those programs are the least out of the sandbox. So whatever Google does, it's going to have to depend on something that may have the weaker security. And that's why the common phrase to say is like a weakest link. Like the security of your whole computer depends on the weakest link. And Google Chrome may be great, but it's not independent from all other dependencies. So right now, I think Adobe plugin, I wouldn't say every month, but at most every other month, you see some new vulnerability coming in. So as long as you are opening PDF file in your browser, you're not completely safe.
Okay.
Yes.
Do you have like an opinion on what the safest browser is, or are they really pretty much all the same? Or
So I get that question a lot.
yeah.
I think I get that question pretty much every time I give something like this. So my question back to you actually is that what do you do with your web browser? Because my answer depends on your behavior. And a lot of times, I think it's really personal thing that like how you use your web browser, what websites that you visit kind of thing. Is a personal matter that I wouldn't usually answer in public. So just to give you like some idea, as I said, if you're using any of the Adobe plugins, then it doesn't really matter what web browser you use. If you're using a lot of the video rendering codecs in your web browser, again, it's not going to matter. If you click on any of the things, say, oh, we need to install new codec for your video, you're probably at least half of those times, you're actually getting the codec player plus malicious add-ons. So it doesn't exactly matter. Internet Explorer, however, was deemed to be more vulnerable because it's tied to the operating system, while other third-party web browsers do not have such great access to the underlying operating system.
Oh, I see.
So Internet Explorer has improved a lot. I think there's a huge difference between version 6 and 7. So if you are an IE person, then I would say you definitely want to upgrade to 8. If you're at 6, bad idea. Don't do it.
No, I don't use it, man.
Okay, yes.
What's your opinion on the phone-to-own contests that are going on like right now, as far as, you know, browsers that get taken down first?
I think it's violence. I honestly believe it's kind of a violence in the cyber world that I'd rather not see. I'm all for defending and I'm all for educating, but I do not quite believe in takedowns, I guess. So I don't think it's something, how do I say? As a security person, I do kind of the poking around myself. And also, I think that should be encouraged in terms of research, but I don't really believe in public face down, I guess. I don't know whether that answered your question or not, but in other words, I haven't fully formed my opinion yet because this is kind of something that I think can be abused. And it can go well, it can be great. And we do this black and red team exercise all the time in security teaching. But still, is it going to be well used all the time? When there is a great chance of abuse, is it a good practice? I'm not sure. So I guess I have to come back to that later.
Thank you.